Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome back. So this question is in continuation with the previous question, which covered how to create a vector of prime numbers which contains all prime numbers between 1 and 1000. So we successfully formulated a program in which we evaluated all the numbers from 1 and 1000 and we checked each number one by one, and then we saved them in the vector P. The vector P contained all the elements which were prime numbers between 1 and 1000. So if I run this program, you will get to see a vector. Let's call out the vector P. If you run this program, you will get to see a vector P containing 168 elements, which are all prime numbers starting from 2, 3, 5, so on and so forth. Now in this part, this will be part 2 of your same question, which is save prime number. We are going to now determine a save prime number, and we are going to make use of the list of the vector, of the list of the elements that are saved in the vector P here. So let's read the question first. The question says is a save prime number is a prime number that can be written in the form 2p plus 1, where p is also prime number. Example, 47 is a save prime. How? Since 23 is also a prime number, so it follows, 47 follows the equation 2 times 23, where 23 is a prime number, plus 1 leads to 47. So mind you, 47 here is your prime number. Save prime number. Now write a computer program that finds and displays all the save primes between 1 and 1000. Do not use the MATLAB's built-in function. So we're not using the MATLAB's built-in function. Is prime. Without using the is prime function, we were successfully able to formulate the vector P. Now vector P here consists of all the elements between 1 and 1000, which are essentially the prime numbers. Now from this elements, from this vector P, we are going to extract, right? We are going to extract those elements that are say prime number. So what I'm going to do is, after extracting P has been successfully saved in my workspace directory. I'm going to use another loop here, and that's going to be a special kind of loop. Why? Let's see. What I'm going to do is I'm going to start off with the very last element. Now the last element here is, mind you, 168th element, right? So I'm going to check the 168th element with all the other elements. So 168th element will be checked with how many elements? 167, and one less. Obviously 168th element will not be checked with itself. So I'll be checking 997 against 991, 983, 977, so on and so forth, against all 167 numbers. And I'll be checking whether 168th wala element, the wala prime number, which is 997, follows the equation 2 times p plus 1 for any element of prime number, for any element of the in the vector saved in the vector B. And if it follows this trend 2p plus 1, if it follows the equation 2p plus 1, I'm going to stop there and I'm going to save that particular prime number in another vector, and I'll call that vector, for example, as save prime, right? Now mind you, I'll not be only checking the last element. Once I'm done checking the last element, I'll move on to checking the second last element. Then I'll move on to checking the third last element. So in that way, I'll be checking how many elements? 168 elements. Now in my case, I'm going backwards. So what I'm going to do is, within this program, I'm going to add an outer loop here, where, for example, let's call n to be my index variable for the outer loop, because small n here has already been reserved for the divisor for the upper part of the program. So what I'm doing is, I'm making use of the function length, and I'm using length function to calculate the number of elements in the vector P, which from the command window looks at the length of P will be how many? 168. Going back, since I'm going backwards, my constant spacing will be -1, and I have to go all the way to 1. So I'll not be only checking the 168th element, which will be saved in length of P. I'll be checking 168, 167, 166, so on and so forth, all the way to 1. And all these numbers, 168th element will be checked how many times? 1 time less, one number less. So for example, for the nested loop, I'm using the index variable m here, and I'll be making use of n variable here to make a connection between the two. So see, the nested loop here says the outer loop will be run here 168, 167, 166, so on and so forth, all the way to 1. And when it comes to the inner loop, so the first time the inner loop will be executed how many times? 1 colon 167 times. 1 colon, I should write 1 colon 167 times. So the 168th element will be compared with all 167 elements. 167 element will be compared with all 167 elements, 166 elements, so on and so forth. So what I'm going to do here is, I'm going to make use of this equation here, which is 2p plus 1. Now, what I'll do is, I'll make use of the if conditional statements here. 2p plus 1, if you go back to the question, the p here is the lower order wala element. See, 23 is the lower order, 47 is the higher order. And 47 higher order I have saved in this index variable. So the conditional expression here is going to be if 2 times this lower order, the index variable, this I'm going to use for array addressing. If 2 times p, mth element of p plus 1 is equal to what? The nth element of p. So see, the nth element of p is what? 168. So the inner loop will be run how many times? 1 colon n minus 1. That means 1 colon 167. So in the first pass, the value of m is going to be 1, right? So check. If the 168th element of p is equal to the first element of p times 1 plus 1. If so, then save this in a vector. Let's call that vector as save prime. Since I'm going to create a vector here, I need to make use of indices. I need to make use of the positions here. So because so far outside the loop, I do not have any save prime number saved. The index so far, for example, is 0. Now once this condition is met, that means we have arrived successfully at the save prime number. In that case, I'm going to use a counter for index, and I'm going to save 0 plus 1 in the first case. So essentially, the index variable will be used for array addressing, and the very first time this trend or this equation is followed, the index value will be revised from 0 plus 1 to 1, and the save prime variable will be introduced, whose first value you are going to introduce as the nth value or the nth element of p. Fine. Since whenever this condition is not going to be fulfilled, if it's false, that means line number 28 and line number 29 will not be executed. So for example, the save primes in the case if it is not fulfilled, if this condition is not true, obviously it's not going to save that very element of p in that save prime vector. Fine. So what I'm going to do is, I'm going to end the if conditional statements, I'm going to end the nested loop, I'm also going to end the outer loop, and I'm going to put a suppressor on the end of each statements. Right after the loops, I'm going to ask it to display the save prime, this variable, and let's see the result. See, so these are all the save prime numbers between 1 and 1000, right? So 983, 887, 863. Now if you want to display against which this 983 actually is, how is this save prime number, against which prime number it is qualifying for 2p plus 1, you can also save it in this same vector. You can create, instead of a vector, you can create a matrix. How? By calling for example, the column numbers, all column numbers, and here you can call out both the mth element and the nth element of P, but here the nth element of P will obviously be the safe prime, and this will not be regarded as the safe prime. So I'm going to show you how. See, so 491 is the lower, is actually P, right? 2P plus 1 में P, this is P. 983 is actually the prime number, is actually the safe prime number which follows this trend. So let's check 983 whether, how is it the prime number, how is it a safe prime number from 491. So 2 times 491 plus 1, see, it makes 983. So it will be true for the other cases as well. 443 times 2 plus 1, 443 times 2 plus 1, 887, so on and so forth. So this second column right here is the list of your safe prime numbers all the way from the between the range 1 to 1000, right? And I'm going backwards. You can do a similar, you can formulate a similar program, but you can, instead of going backwards, you can go forward. It's up to you. So I hope this answers the second part of our question, which asks us to display the safe prime numbers. Thank you.